In the previous videos, we looked at the microstructure of clays and how they behave in different conditions. In this video, we'll examine the main cause of flocculation and/or aggregation, the problems you might face with such systems, and how you can resolve those problems. The rheological properties of the drilling fluid will not stay constant throughout the drilling process. Namely, its viscosity, yield point, and gel strength will increase due to the additions of active solids like shale, inert solids like sand, and other contaminants like salt and cement. It is possible that the viscosity and/or gel strength can increase to unacceptable levels, so it's important for us to be aware of the different factors that influence these properties and how to counteract their effects. Here are some ways for you to influence the viscosity of the drilling fluid. To increase the viscosity, you can increase levels of solids, add high molecular weight viscosifying polymers, flocculate with calcium or other polyvalent cations, flocculate with salt, or flocculate with low pH conditions. On the other hand, to decrease viscosity, you can dilute with water, disperse with low molecular weight polymers, remove calcium by chemical treatment, or disperse with high pH conditions. Here is a figure that shows the effect of salt on clay particles. The top graph shows the potential energy of the clay particles versus the separation between them when they are in a system with little salt. The repulsive forces are much stronger than the attractive forces, resulting in a net repulsive force. The clay particles hence repel each other, reflected by the decreasing potential energy as the particles move away from each other. There is a sizable separation between the particles and the system is deflocculated. The bottom graph shows the same system after more electrolytes were introduced to the system. The repulsive forces have been decreased and the attractive forces have been increased by the salt according to the reasons discussed earlier, and the clay particles are now experiencing a net attractive force. They hence attract each other, reflected by the decreasing potential energy as the particles move closer to each other. There is little separation between the particles and the system is flocculated and/or aggregated. As such, salt contamination will cause the clay particles to flocculate and increase fluid loss, viscosity, yield point, and gel strength. Abnormal levels of viscosity and gel strength can give rise to many drilling problems like use of excessive pump pressure or brake circulation, or higher pressure being required to circulate the mud, lost circulation as a result of pressure surges, entrainment of gas in the mud which may promote a blowout, swabbing of gas or salt water into the hole, sand and cuttings being carried in excessive amounts, contributing to the abrasion on rig parts, swabbing of shale into the bore hole. How is it possible to tackle such problems then? Consider the following recommendations. Pre-treat the system with a thinner to inhibit brine intrusion and loss of circulation. Following the pre-treatment, monitor the system for increases in circulating pressure, yield point, funnel viscosity, water loss, and chlorides, and decreases in pit volume, flow rate, and pH. Such monitoring will ensure early identification and readiness to combat the effects of drilling fluid contamination. Perform a chloride test at bottoms up and before drilling. Treat the drilling fluid with a thinner as dictated by your pilot test. If the chloride count is too high for economic treatment, dump and add new drilling fluid such that the total chloride level stays in line with what is required for an economically controllable contaminated freshwater system. A change in any of the parameters you are monitoring must be followed by pilot testing and additional treatment accordingly. The first indication of contamination will be an increase in circulation pressure while drilling. Make sure the drilling crews are on the lookout for this. Successful drilling at this point will depend on successful maintenance of an inhibited mud system. Here is a list of additives, generally called thinners, that can be used for treatment of salt-contaminated drilling fluids. Phosphates like TSPP, STP, and SHMP. Tannates like quebracho extract, lignites, lignosulfonates like calcium and sodium lignosulfonate, and sodium polyacrylate. In this video, we examined the issue of salt contamination in drilling fluids. We looked at how salt contamination causes flocculation and/or aggregation, the change in the drilling fluid's rheological properties during the drilling process, and what problems the changes may cause and how to counteract such changes.